This is very exciting. Hi, I'm Dale Peterson, and welcome to the Unsolicited Response Show. Believe it or not, this episode is not about the Colonial Pipeline incident. It has nothing to do with it. I thought you needed a break. So we're going to talk to Ulf Lindqvist and Laura Tinnel of SRI International about Project LOGIIC and their Project 12 on safety instrumentation. Before we get to that interview, though, I just wanted to remind you that on June 1st, we opened the call for presentations for S4X22 next January in Miami South Beach. I'm getting really excited about this show. There's a lot of pent-up, great work that needs to be shown. Looks like things are going to happen. We're getting a lot of response on the sponsor side, so we need to put together a great program. We're going to put out the call for presentations, as I said, on June 1st. We'll give you instructions on what we're looking for if you're new to S4. And we're actually going to create a little video, too, to help you understand a little bit about what S4 is about and how you might be able to participate. But if you know of anyone who has a great session, great work, we'd like to know about it. If you have something, we'd obviously like to know about it. We make it real easy. We give you quick feedback. So start thinking about your S4X22 session. And now to my interview with Ulf and Laura. Joining me on the Unsolicited Response podcast is Ulf Lindqvist and Laura Tinnel. They are both with SRI International. Ulf is the Senior Technical Director there, and Laura is a Senior Computer Scientist at SRI International. So welcome both of you to the show. Glad to have you here. I'm excited to talk about this, Project 12 and Project LOGIIC. LOGIIC stands for Linking the Oil and Gas Industry to Improve Cybersecurity. And we're going to talk about Project 12, which was on safety instrumentation. But it may be a good place to start, especially for those who haven't followed LOGIIC over the past decade or so, is to give a 1-minute overview on what LOGIIC is. Ulf, I know you've been involved since the beginning or almost the beginning. Why don't you must have this down now. You must have a great 1-minute pitch. So why don't you explain what LOGIIC is?
Thank you, Dale. We shall see. But yeah, you're right. It's been going on for more than a decade, actually, over 15 years. So LOGIIC is this partnership between oil and gas companies and the U.S. government, specifically the Department of Homeland Security and their Science and Technology Directorate. So this is a initially unique and now a model for government industry collaboration. And it's focused on improving security for control systems used in the petroleum industry. And while I'm talking about that and mentioning government, I should emphasize that Laura and I work for the nonprofit research center, SRI International. We're a contractor to the government, but we do not represent the government. And anything we say here is not the official views of the US government in any way. But we've been supporting this collaboration for as long as it's been going on. As technical experts, we come from the research side of things, and we bring expertise on cybersecurity and the industrial control systems to LOGIIC.
Well, that's great. And yes, you were practiced in that. That was good. So this is actually the 12th project. And anyone who watches the show knows that I always have some pointed questions and some things I maybe disagree with, and we get into a bit of a discussion. But I will tell you this 12th project is my favorite project. So I think it had at least two very important, very clear, unambiguous, actionable things for people to do, which is always, I think, something that's difficult when you have such a consortium like this, to get everyone to agree that, yes, this is important and this is specifically what you should do. So I was really excited to get you on. Now, Project 12 is entitled Project 12 is titled Safety Instrumentation. Laura, why don't you kind of set the stage for this? What were the goals, or what questions were you trying to answer in Project 12?
Sure. So as you mentioned, LOGIIC has already done a couple of projects. We did particularly Project 2 and Project 11 that focused on safety instrumented systems. In this case, what we wanted to look at was not the logic controllers of the safety instrumented systems, but rather at the instrumentation that is used that generates the inputs that the logic controllers use. So we wanted to understand if someone were to be able to compromise the instrument management software, which is usually on a commodity PC. And so it's an IT-based system. And so now you have this IT to OT interface, right? If they were able to compromise that, what could they do to these safety instruments? And could they make changes to them in a way that could cause unsafe situations? So that's what we were really focused on.
And we're going to put up here figure 2, which shows a little bit of the two environments that you talked about, and it shows there the IMS and the AMS, the instrument management system and the asset management system. They go by different names. Now, our audience here is probably more familiar with traditional ICS as opposed to the safety components. Do those have a similar role to an engineering workstation in the sense that they're actually configuring and monitoring and well, maybe not monitoring, but configuring and managing those smart instruments in the diagram?
Yes. So the open source version of that is Packware, but then there are multiple vendor products out there that can be used. Some of them are paired with SIS, some of them are not, and can be used with any SIS. And these are used by operators to configure and monitor the status of these instruments while they're in operations.
Okay. So obviously very important things. I think most of the audience knows how important it is. If you can get to the engineering workstation, you can do a lot of bad things. So a similar sort of thing. So there were, as I took it, there were 3 major technical areas you covered. And we've flashed up, and we'll continue to do it, the link to the actual paper. The paper itself goes into a lot of the team, the methodology, the assumptions, the limitations. So really good explanation of how you did what you did. But I want to focus more on your findings than that. Because just even in your executive summary, if people are thinking this is just another report, I pulled out 2 quotes. The first was, "The project revealed numerous consequential and recurring findings that indicate a pervasive industry-wide security problem in safety systems." That's a serious quote. And then another one, "These attacks required a little," I didn't even write it down, but a low to moderate level of effort to exploit. So these were significant things that didn't require the smartest people in the world, highly resourced, to find. So that was, I think, really important. The 3 that I pulled out, and you can bring in extra ones if you want, but let's start with the first one. And obviously, since I like the term insecure by design so much, this one resonated with me. And in a sense, I was a little disappointed to see it in there because it's the problem we've lived with for 20 years. But the first one, and either one of you can pick up on this, but you talk about the fact that the HART IP protocol is insecure by design, no authentication, no encryption. Was that something that surprised you, or is that something you knew going in and just was going to be an easy finding in the report?
So for me personally, it was surprising just because I don't have an ICS background. My background is cybersecurity, IT-based cybersecurity. And from my perspective, this is just something you don't do, right? But I think that the LOGIIC members who are familiar with the HART protocol and the HART IP protocols kind of had a sense that this might be a problem. And that's why they specifically wanted us to look at this. To your point, the HART protocol, and this is not the first time people have pointed out that there are issues with this protocol. I have seen references to it from, 2013, people pointing out that the protocol is completely open, no authentication, no encryption.
And I can add that this is something that we see in other applications as well. Some IoT protocols for Internet of Things, consumer type devices, for the CAN bus on a vehicle, for example. It's this assumption that, if you can communicate here, you're already implicitly authorized, and there's no authentication, no encryption. But as we connect these types of devices and networks to regular IT systems, that's when you get a problem, because then you get a path for someone to get to it.
Right.
And
Right.
I could go on my typical rant here, just like I have with level 1 devices and DNP3 and Ethernet IP, although those have secure versions now, so we're getting there. But actually, when you look at the deployed base, access equals compromise. You can do what the protocol allows you to do, and I'm going to put up here from your report table 2, and for those that are just listening, it has things like disable write protect, put in fixed current mode, write device alert logs, relay launching behavior, administrative sort of things, management sort of things that you can send to the instruments that support them. The report says that not all instruments support all these commands, and some have proprietary commands as well. But basically, if you can either man in the middle or find a way to access this, just like most of the ICS protocols, you can do some bad things. Was there anything unique about the HART IP protocol? Because one thing jumped out to me, but I was curious if you thought there was anything unique compared to other protocols.
Well, let me first distinguish between HART and HART IP. So
Okay.
HART is the protocol that the instruments use to talk to basically to the SIS. So that's on the back end. They are wired into the SIS, and there is this HART is superimposed over these analog connections. HART IP is what allows the IMS, which is an IT-based system, to talk to the instruments. So it's an IP protocol that is an envelope for HART, and it sends the HART packets over to the SIS, which then passes them on to the instruments. Or in the case of the MUX, in that case, you're actually serial connected to the MUX. So there's no HART IP at all there. You're just talking HART. And
that's, just to interrupt, that's similar to a lot of protocols like Modbus,
Sure.
Modbus TCP, and SIP, and Ethernet IP, and Profibus, and Profinet. So
Right.
it has that. But I think that's an important distinction. What I learned, I did not know this, that there's really no distinction in the protocol between read and write commands. There isn't the concept of a read function code and a write function code, which was new to me and actually quite limiting in security then.
So that is true for device-specific commands. When you look at the HART common and universal commands, those are either read or write, or read and write. And that's defined in the protocol standard. And so SIS solutions can implement blocking for the write operations for those. The problem is these device-specific commands that get at the device-unique features, right? And the HART protocol has no concept of read versus write for those. And that's where we were able, even when we blocked things on the SIS, we were able to basically get around that and continue to make device-specific changes.
Well, if we go back to your figure 2 then, I have seen, for example, that like a Tofino, a read-only Modbus Tofino, I've seen that used between safety and control, where the control system could send read commands, but it couldn't send write commands. So you could do that to the SIS. You could put essentially a read-only capability between the PCN and the SIS. But if we look at your architecture 2, you couldn't have read-only between the IMS or AMS and the smart instruments, is what you're saying. Is that right?
Sure, right, because the MUX is just a straight pass-through. It doesn't do any kind of filtering.
No,
Right,
but
so-
if I put something in between there, in that dotted line, if I put something there, the protocol doesn't let me say only allow reads at that level, is what I'm hearing.
Right. So what you would need to do then is use the write protection that's on these safety instruments. So the standards require all the safety instruments to have write protection in order to get safety rated, right? And so in that architecture 2 case where you've got the MUX is mediating the communications between this management software and the instruments, you would then want to use that write protection on the instruments. And in fact, I would suggest you use it in both cases, but that's, because of some of the things we found.
Yeah,
Right.
I want to get to that. To me, that was one of the most important findings. The only other thing I had on Hart here was, and Hart IP, is that there was a small mention and a footnote to a secure version of Hart IP that was coming.
Yes.
Are you seeing that now? What does that have? What is that doing? I don't know if you're up to speed on that, or is that another Laura question?
That would have to be another Laura question.
Okay.
So I have not looked at it personally. This was released in, I think it was July of last year. So it's right in the middle of the pandemic and our assessment that got drug out because of the pandemic. And after the fact, we did a paper analysis. I sent it over to one of the guys who did the hands-on assessments. And he took a look at it and said that it seemed to have a lot of the properties that we were calling for in the recommendations. So it's basically like Hart with TLS built in or something like that, right? So it does get you that application to application encryption. So that's a good thing, right? And I think this is a really good first start for the industry. This is going to help remove the network side of the attack surface. But they still then have the issue of, can you compromise the IMS platform itself through other means, right? Because network isn't the only way you can compromise that platform.
Right. Now, maybe a question on that is that something that LOGIIC then tries to do as they find these things? Do they? So even if the protocol exists, we're seeing this with other secure ICS protocols. The actual deployment and use of them and integration into products tends to have quite a long lag time, even for greenfield projects. Like we've got now secure, SIP secure, and Modbus secure, but we're not seeing them put in even in new projects, let alone retrofit. Does LOGIIC envision itself as going out to any of these smart instrument manufacturers and saying, this is what we would like to see?
Yeah. So this is where the vendor relationships come in. So companies that are members of LOGIIC are these big oil and gas companies, for example, Chevron, Shell, Total, that of course are the big customers of the instrument and automation vendors. And LOGIIC has all along kept a very open dialogue with the vendors. And one of the goals of LOGIIC is to stay vendor neutral, but also make sure that, products are improved security-wise, so that helps across the industry, and not just the LOGIIC members, but all of those who are customers of the automation and safety vendors.
And we've seen this work before, not through LOGIIC, but through the oil companies themselves. Maybe 15 years ago with Eric Byers' Tofino, some of the oil companies wanted to have a certain level of protection at a certain point in the network, and they said to their vendors, we want you to support this. And they didn't say you had to buy Tofino, but we want this capability. Right. And they put it in RFPs, and it changed things.
Yeah.
A lot of the vendors integrated it in, they created modules. So the power that both I guess the asset owners and the vendors, and probably DHS, can have in driving requirements could be quite helpful.
Yeah, absolutely. And I remember this one of the early successes of LOGIIC, LOGIIC project number 2, which was the first project assessing safety instrumented systems. And after the conclusion of the project, we invited vendors to come back and talk to LOGIIC. And when those vendors said, thank you for showing us these issues, we will go back and improve our products accordingly. That was the first sort of major success for LOGIIC, because that really improves security across the board.
Mm-hmm. Okay, let's dive into what I think. Oh, I'm sorry. Did you want to say something, Laura?
Yeah, I was just going to say that I've already heard from LOGIIC vendors or LOGIIC members now who are already taking lessons from Project 12 and putting them into their procurement. So, yeah, I mean, it's already happening, right?
Fantastic. And probably related a little bit to what I think was the big, simple to understand, actionable issue. And this was software versus hardware-based write protection. So you earlier said that the standards say that these smart instruments need to have write protection. And the report found that software-based write protections can be bypassed with little effort. That's a quote. And it said all tested device software-based protections were bypassed during the test. So these software write protections really are just keeping honest people honest, right? If it's
Yes.
for people who are not trying to circumvent them, yes, it will stop them. It will say, oh, hey, you're not allowed to do this. But if you have access and you want to do it, you will
Yep.
bypass them. So maybe if we say the software protections are bad, and we could go in how they were bypassed, but I think even if they weren't easily bypassed, I think the core message is still the same, that there should be hardware-based write protections. Can you give us an example of what is a hardware-based write protection?
Sure. So they were just as with software, right? The hardware was implemented differently on different devices. In some cases, it would be a physical switch. In some cases, it would be a jumper, and you'd have to actually open the device and change the jumper. And so I think that one of the issues that needs to be addressed is the usability of hardware-based protections, because they're not necessarily the easiest things to use, and they are physically on the device, which may be in a location where it's difficult to reach, right? And so we have this balance between saying, okay, you really should use hardware protections because they do the best, right? They are going to give you the most protection. We couldn't bypass them. And creating a solution that is so difficult to use that the operators out there just don't use them. And then we're in a worse situation than we are today, right? So we really need to think hard about this and what the true solution is.
And it's this dilemma because, as you know, many of these instruments are deployed in very harsh environments, and there are lots of benefits to remote control. But it's this trade-off where, if the operators easily can remotely control something, there's always a risk that an attacker can do that also.
And you also, this is a little bit different, and even in the process side of it, the control side of it, the PCN, there's a difference in sector and even in site as to how often these things change. But in general, in the safety area, they change much less frequently, don't they? You're not going in every week or every month to change these settings if you do it right, or do some people actually change them that frequently?
So I'm not a safety system expert, and I can't really answer that question. My feeling based on talking with the LOGIIC safety system experts who helped us with this is that you're correct there, that these aren't changed very frequently. And certainly the devices that are changed, maybe once a year or whatever, the frequency is, if it's very infrequent, please use that hardware protection, because that is your best solution here. But the other issue is that in the sample set we had, which was not representative of everything out there, but it was representative of what the LOGIIC members use. All systems did not have these hardware protections, right? It was a less than 50% kind of thing.
Yeah, I saw in your paper I had noted that it said only 33% of the devices in the project had hardware-based write protection. So, and I can understand that because, as you say, it's an ease of use issue. Their customers probably like the fact, and even the software-based write protection and the hardware can be turned off, right? It probably comes default turned off because you have to program it up first. I'm still having a little trouble, though, with the difference between the line between hardware and software. This is a discussion I've had with Reed Whiteman, who used to work for me for a while. If I look like at a PLC, a lot of them will have keys in the front that you can turn run mode, program mode. And so in run mode, in a sense, you can't change the programming of the system.
Right.
But that key then is providing, that key switch is providing an input to the algorithm. And if you can get on the system, you can change what that input means. You could, for example, you could change it so no matter what the key switch position is, it always thinks it's in program mode. Is there that same issue with hardware protection? Can hardware protection be hacked while it's off?
That's a really good question. I think that it's possible, depending on how it's implemented. You would have to get access to the instrument, right? So this is not something that you could necessarily do from the asset management platform. And remember, so for our project, we launched all the attacks from that platform because we were trying to understand how you could compromise and use that platform, right? I think that this is something that someone should look at, and it's going to completely depend on how it's implemented, right? So is it truly a physical switch, or is it something that software is reading, as you mentioned? And we've seen that in different assessments that we've done.
Mm-hmm. Yeah, and you did note that device write protection implementation is inconsistent even across the vendor products. This can lead to confusion and accidentally unprotected devices. I was curious about that. So you mentioned the convenience of being able to change it, but were you also seeing issues with just how easy it was to understand the current state of the system? I would think that might be an issue, is how do I know whether it's write protected or not? Or is that something that flows up to the IMS, AMS automatically?
I think that's how most people would know is by looking at the state in the IMS or AMS system. Yeah.
Mm-hmm. And I had a note here that this seemed to me to be the finding in the report. To you, is this one or two of the main findings in the report, that people just need to be moving from this software-based write protection to hardware-based write protection?
I think we need to be moving to better write protection. Okay. And I'm not sure what the answer is. I mean, from what we found, hardware does look like the answer. But again, harken back to what I just said, if we create a situation where it's really hard for people to use this because of the way they run their businesses and their operations, then that may not be the right answer. But we certainly need something that's a lot more difficult to bypass than what we have right now. Because what we have right now was basically simple passcodes, and they were easily guessed, could be intercepted, on the network because the traffic was unencrypted. I mean, it was the access protection is a serious issue here.
And this is where the issue of cybersecurity expertise comes in. To an operator, if you have software-based protection, it may look just fine, right? Why wouldn't this software switch protect me just as well as a hardware switch? And as you suggested, Dale, we may not even know if is how the hardware switch is actually implemented and if it's truly non-bypassable. So it's in the details. It requires expertise, and we can't expect operators to necessarily be able to tell the difference.
Right. I think that, to me, this, again, wasn't a terrible surprise. I think maybe just the fact that it was so simple is a little bit of a surprise, and I think the fact that there is some hardware is a positive thing. It reminds me a little bit of what we did back in Project Basecamp with PLCs, where even though I would imagine some of the technical experts you had involved were pretty confident they were going to be able to achieve this, the actual doing it and documenting it and presenting it to first your LOGIIC members and then to the community is a huge deal. It's one of those things that I wouldn't call it a dirty little secret, but it's something that people knew and just kind of said, yeah, this is the way it is. We have to live with it. And actually shining some light on it, I think, is terribly important. And one of the reasons why I really liked the report. Let's jump to the third area. And this one, I think, was somewhat new to me and is going to be quite new to people. And that's, you looked at these DTM files, these device type manager files. Laura, first, why don't you explain what a DTM is in this environment?
Sure. So the IMS software or the AMS software needs to be able to talk to and configure devices. And these devices can be from any number of vendors, right? And so the people who build these management solutions do not have intimate knowledge of the devices and their device unique features. So what the industry has done is created this device type manager. It's essentially a plugin, if you will, that goes into or onto the platform, and it gets loaded into the process as the IMS software runs. Okay. And so in a DTM, it's both executable code, it's a DLL, so a Windows DLL, and configuration files. Now, there is an alternate to DTMs called a DD file, and that one is just an ASCII text structured file. Not as dangerous because, as you can imagine, getting a piece of executable code in a DLL and loading it into your asset manager, if you don't know where that thing came from, right, and you don't know that it's the right one, that can be very dangerous. But we were also able to find things with just even the configuration files and modifying those that we could do some pretty interesting things with.
Yes, that's just amazing too, that your report said that a lot of these DTM files, in fact, I think all of them, did you find any of them that were digitally signed? Because what I read seemed to indicate that you basically download these DLLs from a vendor site, and if that file had been corrupted or had bad code in it, it was going to be loaded up. Was anyone protecting them?
I'd have to go back and look. I think there was maybe one that maybe did, but the practice in general is just not to sign, and not only not to sign, but the asset managers, when they load these things, they don't even ask questions. They just load it. It's there, boom, they load it, right? They need to be enforcing that these things are signed by some entity that they trust, and that's just not there. And this is an easy thing to do. Yeah. Right. This is not something that would take a lot of effort for these vendors that create the DTMs to go ahead and sign this stuff. The people who develop and sell these asset managers, they can put out an update on their systems, and you just push all this out to the industry. And this could be done, over the course of a year. This is not, rocket science here.
No, there was a time when IT updates weren't signed many years ago, but we've been used to that for such a long time now. We automatically update things because we know, all that signing stuff is handled in the background, but we don't necessarily see that in these specialized systems.
And that's a clear win. I mean, if the vendors, not only the ones in LOGIIC, but others just say, hey, I can't use your DTM until you sign it, and you put that in place. I think, Laura, your idea of having it integrated into the product is nice, but quite frankly, with a lot of signed files, that doesn't occur today. There's an offline process of verifying it before you bring it into an environment.
Oh, so absolutely.
Even as an intermediate, that could be something, literally a vendor could solve this in a week. They could develop the infrastructure to do this, and
they hand out the hashes and in the instructions and say, here's how you verify it, and the operators do it before they even load it on the system.
And in fact, if any vendors are watching this, if you put out signed DTMs, I will promote them in my Friday news and notes. I'd like to see vendors jump on this. I mean, and it would be great. I would think the LOGIIC site could say, hey, these people started signing their DTMs. This is really a great thing. It's an easy win. I did want to note one thing, and I'll include a link to it in the show notes, that even if it's signed, we potentially have issues because Alexander Bolshev, who is just a brilliant researcher, looked at 114 DTMs back at S415, and he found that 25% of them had vulnerabilities in them. Some of them allowing remote code execution, some of them allowing crashing and such. And even though only 25% of the DTMs were vulnerable, there's usually a lot of DTMs per device. So he found that 2/3 of the devices had one or more vulnerable DTMs. So I think the key thing is these are executable code that could be done right or maybe not. And I think that's something that people need to start thinking about.
Right. I could not agree more. And in fact, another one of the recommendations that we make to vendors is that they need to use available software analysis tools, and they need to make sure that they are not putting out vulnerable code before they get it out into these operational environments. Right. I mean, these tools are they're available. Right, they can find the buffer overflows. They can look at the interfaces and find, there's problems with the input parsers, so they can fix these things. This is, again, not rocket science. And I think that's where we keep getting back to with this project is that we really didn't discover anything that was like totally new. I mean, this is all kind of standard stuff that, people in, with an IT cybersecurity background already know, right? Mm-hmm. And we need to do a better job of communicating with folks in these other domains and helping them secure their environments.
Mm-hmm. Okay, let's get to the last issue, and this is the one where maybe I have my small issue with your report. And this is really, as you said, Ulf, this is your third bite at the apple, kind of the safety apple. If you call wireless heart, maybe the fourth bite. But projects 2 and 13 looked at safety systems. This has looking at safety instrumentation. When I look and I'll put this figure 2 back on, I don't see anything saying you should not connect your PCN to your safety system. There's some talk about using SIS security controls, but quite frankly, I wouldn't want my PCN having the ability to do any sort of control at all on my safety system. I guess the question is, why hasn't this project or other projects actually said the only access that should be allowed is read access, and anything that can do this administration or control like an IMS or AMS should not be on the PCN?
Right. Well, I can start. We can see if Laura can add on. So I referred to the Project 11 report as our latest look into how safety systems, should or should not be integrated. And there's various degrees of integration. And of course, not surprisingly, we found that more integration, leads to more security vulnerabilities.
Right.
But then there's also, the reality of some of the settings. I mean, I'm obviously all for segregation, separation. In my view, security is all about separation. You need to keep, things of different priorities separate, keep separate the good from the bad, etc. All that. But in some settings, because of the business requirements, there's apparently a need to control things together. So it all depends on the situation, and every operator have to make a thorough risk assessment of their situation.
Yeah, I guess I just was hoping for I've always hoped for a stronger message. And even in this example, like the IMS and AMS, it's hard for me to think of a case why they need to be on the PCN. They're just managing and administering these things, except for ease. I mean, I can understand it's more convenient, but other than that, I can't think of a reason.
So that's actually a really good point. Thank you for bringing this up. The test team had this discussion. One of the alternative architectures we were toying with was this idea of, take the IMS, AMS, whatever you call it, and network segregate it, right? So just disconnect it from the network, and all that it does is manage these instruments. And that sounds great, and it certainly will reduce the network attack surface, right? Because you can't get to it. There are a couple of issues that come with that, though. One is the platform can no longer get automated system updates. It's running on Windows, right? Windows is vulnerable, and we didn't look at how we would use, Windows vulnerabilities to attack the system. We ruled that out of scope. We know it's possible, right? Mm-hmm. But the point is, if the system is not getting the regular system updates, then what's going to happen over time? Well, it's going to become more and more vulnerable. And when somebody brings a new DTM or DD in, or some other piece of software that's required to be on this system, and they load it on there, we now have a problem. They could actually use vulnerabilities that have been patched, right, in Windows, but the patches aren't on the system. So that's one issue. The other issue is that a lot of organizations want to have these endpoint monitors on their systems so that they can have an overall cybersecurity view, like in a SIM, right? And so if it's not network connected, then they can't include that system, right, in their monitoring. So there's trade-offs. There's no perfect answer. And what we want to do is provide knowledge and education so that individual asset owners can look at their own environments and determine their own risk and make the best decisions for their specific operations, right? And that's one reason we didn't even attempt to calculate any kind of risk score, because it really depends on which environment the safety system is in, right? We don't know the impact, but the individual asset owners do, right? So all we can do is arm them with the knowledge so that they can figure out what is best to do for them.
Right. Yeah, absolutely. The key is really to enable those informed decisions, so that when they make the risk assessments, they actually have a better view of what the real risk is, that they don't, for example, put all their faith in this software-based write protection, just as an example. So by providing the asset owners with this kind of information, they can make better decisions, but ultimately it's up to them.
I understand, and I don't think we're going to reach agreement on this issue. And I understand that is actually one of the challenges, and we see that with ISA and other things. Anytime you have a group of people, you might have differing opinions, and you have to reach some sort of consensus as to what are the recommendations. So I do understand the difficulty of that. I will note, though, that one of the things I liked, it was a simple control that was sort of along the lines I'm saying. It said, consider turning off the IMS AMS when not in use. You know, awful hard to hack something that's not being used, and if you're only using it once every 6 months to make a change, why is it sitting there available to be hacked? So that was great.
And that has the same issue, though, by the way, is not getting those automated updates. Now, let me come back to that real quick. You can always bring in policies and procedures, right? So that will help with these things. So you could make it a procedure that once a month, whether it's turned off or it's disconnected from the network, you send somebody in to apply the system patches, right? It's just that now you have to, be cognizant of that and make sure that somebody is doing that, right?
Yeah, no, I hear you. I've been on the record a long time and put out something on the value of patching when you have insecure by design protocols and systems. It's certainly questionable, but we won't go down that path. I guess I've asked you a bunch of questions. Maybe I'll go a little broader and give you a chance to talk about things I didn't ask. Was there anything, Laura, that you found surprising in the results, or even more important, something that was very important in the results that we haven't talked about?
I'm not thinking of anything. I think you've pretty much covered the big things.
Okay. Yeah. And how about from the vendors' perspectives? Did your vendors come back to you as they were getting these results? I don't name vendors, but did any vendors say, "Wow, this is really interesting. We didn't know that"?
I don't know. Nobody said we didn't know that. That doesn't mean they did or didn't know that. But we did have vendors come back and say that there's some really good findings and recommendations here, and we're going to go back and take a look at this. So that was a good thing.
Ulf, how about you? Was there anything that was surprising to you, or anything important that we didn't talk about that the listeners should know about?
No, I don't. I think we covered most of it, but it's really important to see when you sort of, in a way, retrofit, traditional analog, more or less unhackable sensors with all these smarts, which really is what HART is about. That you have to be really careful in what you allow, happening. Yes, it makes great business sense to be able to remote control everything, but as we discussed earlier, you really have to be careful how you expand that attack surface, and especially when it comes to something so critical as the safety systems that are really there to prevent things from blowing up.
Yes, the analog to the comparison to the IIoT is that you made earlier, Ulf, is very apt there. Although here we're talking about systems with potentially huge consequences if hacked.
Exactly.
IoT. Maybe not as large, but maybe more distributed. I guess, is there any follow-up to this? So you've done this work, you found a bunch of things. In some cases, you found some vulnerabilities. Is there any sort of follow-up or disclosure that will happen as these things get fixed? How is that data processed?
Sure. So LOGIIC keeps a matrix of all the findings, and they follow up with the vendors. And so they check in with them periodically to see what has been fixed and what hasn't been fixed. because that's one of LOGIIC's metrics, to see how much of an impact they are actually having with the vendors and the vendor products. And so they have to have that traceability to figure that out.
And maybe this is more of a project organizational thing, but is there any sort of follow-up then where after a certain period of time where your participants have the information that it becomes available more generally, that there was a vulnerability in this version, there's now a more secure version available? Does that ever get out to the wider community?
Well, I think what we've seen in this report is that LOGIIC is increasing the information that we're putting out to the community for the good of society and industry. So I think you'll be able to see more of that coming. And we mentioned earlier how LOGIIC Project 2 and 11 were about SIS. So 11 was really a revisit of the original project to see what had changed and how the technology field had changed and what the new security assessments would be. So that was really a very big investment in follow-up. And may want to edit that part out. Come out
I will follow that up with so yes, we have moved towards more disclosure, trying to make sure that we can give truly actionable information to asset owners, not just in the oil and gas sector, but anyone who uses the safety systems. There were some product unique findings. We do not disclose those. As I think you're aware, all the vendor participation is covered under non-disclosure agreement, and LOGIIC will never reveal who the vendors were. But we do demonstrate and show those vulnerabilities and findings to the vendors directly. We give them the test cases, we give them the attack code so that they can repeat and duplicate what we found. And then we let them handle it through whatever their normal chain is to address it and to let their customers know.
Okay, so the vendor makes that disclosure decision. Okay.
Yes.
And that's probably something we see that in a lot of projects. That's one of the conditions on participation often. So maybe the last thing here is there a project 13? Or, well, first of all, are you skipping right to 14? Are you skipping unlucky number 13? And what is the next project? Has it been announced yet?
No, it hasn't been announced yet, but we will let you be the first to know.
I was hoping for a scoop. I didn't see it on your site. I thought maybe you'd give me a scoop. But anyways, I really appreciate you both coming on the show. As soon as I read the report, I knew I wanted to get you on. As I said, I think there's some great work here, actionable, important, and easy to understand. And to hit all three of those is very rare in this space. So I think the team, everyone involved, yourselves and the other people who did the work, and even the vendors and the government for funding it, everyone deserves a pat on the back this time. So thank you. Thank you for coming.
Thank you so much.
Thank you, Dale. Thank you for having us, and thank you for your support.